Hello everyone. In this short video, I'll walk you through the work I did during my internship at Coriolis Technologies. The focus of my project was on prompt optimization, a powerful technique to improve how large language models perform across different tasks. The motivation was simple, but critical prompts are the control panel for LLMs. A well-crafted prompt can be the difference between mediocre and exceptional output. So, automating and optimizing this part is both impactful and essential. My initial task was to create a fully working MCQ generation system. In the beginning, the prompts were generating shallow, fact-based questions that didn't test any real understanding. For example, what is the speaker's name? Or, how many examples were discussed? These types of questions lacked reasoning and failed to capture the core concepts of the content. To fix these issues, I used a trial and error approach to improve the prompt quality. I added clear guidelines for framing questions, ensured a balance of difficulty levels, and enforced a fixed JSON format. I also introduced a second LLM to evaluate the quality of each MCQ. This flowchart shows the complete pipeline. First, content is split into chunks. Each section is sent to LLM1 for MCQ generation, followed by a second LLM which evaluates each MCQ for correctness and depth. Finally, after checking all tests, all results are saved and returned. One major challenge was that LLMs often failed to follow the required JSON format. To fix this, I added retry mechanisms to reprocess faulty outputs. But manually tuning prompts every time was slow and not scalable in the long run. Enters DSPy, Programming Not Prompting LMs. DSPy made prompt engineering much easier by letting me define the logic and code instead of plain language. I could specify input format and output format, like a fixed JSON format. Then, by providing a few good examples, DSPy trained itself to find the best prompt. The results were as good as carefully handcrafted prompts without all the manual effort. This flow shows how DSPy handles prompt optimization. First, I define the input and output schema. Then, I provide a few example input-output pairs. DSPy uses these to train a prompt that maximizes performance. Once trained, this optimized prompt can be reused reliably across similar tasks. After training the prompt in DSPy, I plugged it directly into the LangChain pipeline. The results stayed consistent, which showed that the optimized prompt logic works independently of the framework being used. This comparison shows the strengths of each setup. LangChain offers better modular control and integration, while DSPy is great for optimizing prompts with minimal manual effort. The hybrid approach combines both using DSPy to train the prompt and LangChain to deploy it, giving the best of both worlds. I also applied the same optimization strategy to other tasks like generating user stories and test cases. The approach stayed the same: define the task, demonstrate it with examples, train the prompt using DSPy, and finally validate the outputs for quality. To sum up, I explored both manual and automated approaches for prompt optimization. Using DSPy, I built a general strategy: define, demonstrate, train, and validate, which worked across tasks like MCQ generation, user stories, and test cases. Most importantly, I showed that optimized prompts are reusable across frameworks like DSPy and LangChain, making the solution both scalable and framework independent. Thank you.